Hello. All right. Yo, Blue. You made a third. You made a 3D cube ever in Zig. I feel like there's some word missing in there. Cool. With well, OpenGL or Vulkan, or how did you do it? Yo, Penguin. What's up? Okay, so I am currently working on the pipelines a little bit and trying to figure out how they should work, really, because I've been going back and forth on contexts and values from returns and all that. Alright, cool. ASCII. Ah, cool. And I decided that, well, we probably need streams. I'm just gonna try it. So I started to build the streams. This is another, well, we have had streams before, but I built this stream, which takes a source, which is a reader. So it's an IO reader. And basically turns it into my stream interface type here. And of course, it only works with the strings right now. However, but it's pretty simple. Like most of it's basically the usual implementation. The only differences here is like we have a buffer that we read into with read slice short. Now, if the bytes read are less than the buffer length, that means the stream ended. So we're checking that here to set completed to true, which we will return next time. And but otherwise, we will capture the bytes read into this bytes next thing here. However, I do realize that we actually need to dupe this here, so we need to like let's see, hang on, we need to do like get allocator. Okay, let's get the allocator here. Self stream get allocator, and then try allocator dupe. And there we go. I guess we could also, that's fine. So that will return a duped thing there. Cool. And then the consumer of it would have to then consumer needs to free the returned strings. So you can use that to read from a file, for example, or the pipes. No, wait, that's the byte transformer. This is the IO reader here. You'll delete it. Why? Just it's gonna check. Oh, cool. Whoa, with colors as well. That's awesome. Hello, Deputy Cracker. Try Cracker. Bro, is calling such long. Yeah. I try to code everything. Welcome. Oh, I see. Well, don't worry about it. It's fine. That was really good animation, I have to say. What kind of ASCII, like, are you using some kind of, like, did you build the ASCII renderer, or how did you do that? Okay, so this will read from a reader, as I said, so that's fine. And then I was like, well, we could potentially, you know, read from a byte stream and turn it into anything, really, with a byte transformer stream. So basically, because we have this transformer that can transform any type to any type, basically, we can then turn a stream of strings into a stream of anything. So basically, how it's gonna work is basically we're gonna try and read into this buffer here, which has the same size as the size of t. So we're filling up this buffer, and once it's full, we have the next item. So then we can convert it into the type that it is with that something there. And that should work. I mean, for structs, it's gonna be a little bit weird though, because I mean, okay, so if you have like pointers and stuff, it has to be in the same like execution context. But yeah, it's gonna work, I guess. It's like, yeah, if you're in a runic execution and you try to run another runic file, you have to do it in like a runic way, because otherwise you're gonna lose that interoperability between the streams. But basically, this could allow us to stream well, what would this actually do for us, actually? I mean, it could help us maybe turn I don't know. I just thought it was fun to build, actually. So depth drive cracker, are you you're a developer, or what, or what's up with that? You make a screen buffer, use triangles, basically drawing triangles using screen. I can give you a call. Okay, but how do you determine like the ASCII characters? Like, did you build some algorithm for that, or because it looks like it's reacting quite nicely to the actual like content? Like, what do you call it? Like a rasterizer, ASCII rasterizer, or alright, so I just wanted to build this basically because I thought it was, hey, it was cool, it's possible. Although it can't do everything, but I just thought it was kind of cool. So the idea is we fill this buffer up, and once it's full, we have the next item, and then we push that out from here. And also the ideas with these streams are that we're basically gonna try to put streams in like a list of streams that are kind of active, and then they would have to have some sort of destination as well, because we can't consume the whole stream at once, because the streams need to be kind of async. So what I'm trying to do is, well, I could use a thread, but I was thinking like, hey, I want to try to do it single thread. So I'm gonna put them in kind of like a task list or something, and the streams will, it will chug along, because you can grab a little piece at a time, and it will, you know, churn through and give it to the next one and so forth. So that's what I was thinking. And then like somehow, I'm not sure exactly how, but somehow we need to churn through this streaming thing. I'm not sure exactly where we would put that, because how it works is like basically, I guess we could, I'm not sure actually. Maybe we have to make a thread. I mean, we don't really have to, but it would be, probably don't want to build in this whole like execution thing about that. Maybe we should just do a thread. I was just like wanting to avoid that because of, you know, issues with the whole multi-threading thing. I'm not used to do multi-threading programming. But basically, we could have a thread in the background that churns through all the streams and provides and puts them into their destinations. We just have to make sure that there's not gonna be any issues with that happening at the same time as we are, you know, evaluating or executing the rest of this script. Like for example, let's say you set up a background process and then the scope gets popped. So that cleans up the whole scope. Then the background process actually have to be somewhere else. It has to be like in a global scope. Or if we need information from the scope, we could also, each time you do a background process, we could capture maybe kind of like, well, the current execution context, like a closure, if it's needed, and put it together with the stream as a task to run, and then that would run it in the thread. And I guess some of the evaluations are gonna be blocking. Like every time you execute a command that is not a background process and that it's not piped into anything else or redirected or anything like that. Like when you're at the end of something that is not a background process, then that's gonna be blocking. Thank you, Piano. Alright. Well, anyway, I just want to finish this here. Anyway, like that could all work with these streams. Like these streams are gonna be used as, you know, the mechanisms for which we can pull data, and then it's basically just pulling data. So and then you would have a string of things pulling. Like each stream pulls on the previous stream, pulls on the previous stream. It's basically like a connected thing of streams that each one is gonna pull on the next. So that's how it's gonna work. Maybe we don't actually even need to have a separate thread for that. I mean, we're gonna need it for background processes, I think, but well, okay. Requires a little bit more thinking there. But the source next of this one is pretty kind of straightforward here. First we get the next string out of the byte stream. That can be any stream, but it has to be returning strings. And if we're completed, then, well, if we don't have any data yet, we return null. If we get an event, we're either completed, which will also do a check here. Like if we were in the middle of reading another entry, that, like if cursor was not null, that means that, or 0 I mean, that means that we were in the middle of reading another entry. So we return this error here, stream or read aborted. Otherwise we're fully completed successfully. Otherwise this will try to return, like if we get some data, more data here, we try to produce the next thing, and that's where I am right now. So basically here we are going to do like there's a couple of scenarios, like if we can fill up the buffer. So basically if we can fill up the buffer, transform it from a string of bytes to the 2t and return it. We also fill up eventual fill up buffer with eventual rest bytes. So we could have rest, like bytes over from the fill up. Yeah, I mean that's basically it. If we can't, then set. If we can't, just fill up until the source is empty and set cursor to new position. So basically, let's see, how do we know if we have, it's basically going to be a loop as well, because we don't know if there could be several items with which, you know. So let's do a while true. And we'll say byte transformer looks difficult. I mean, in essence, it's not really that difficult, really. It's just that there's a lot of things that has to be in place. It's like a chain of things. So basically, when you have like an advanced problem, you try to break it down into smaller parts and then solve each one separately, instead of trying to solve the whole thing at once, because that's going to be difficult. But what I mean is, like, the whole thing could be, you know, the whole thing is like kind of complex, but each individual part is like, you know, it's pretty comprehensible. So that's what I'm trying to say. I'm not saying that I don't say that everything here is like super easy or anything. But I also don't want to. I also don't want to like mystify anything or trying to say that, yeah, this is super complex or anything like that. You just have to get good at kind of breaking problems down into smaller bits to kind of see how you're gonna fit everything together, and then you know, the more you practice programming, the better you're gonna be at that sort of thing. Okay, so I'm thinking like we have this while loop, and we're gonna see. Let's make a cursor into n. because we need to know where we are. Like if we consume just a piece of n, we need to know where we are on that. So here we're gonna say bytes needed for the next item is gonna be so that's gonna be like buffer length minus the cursor. That's how many bytes we need to make the next item. And then we're gonna say if, oh yeah, and then we're gonna say how many bytes do we have left to, how many bytes do we have left in the source left, bytes in source left. That's gonna be n length minus n cursor, right? We have two cursors, one for our own buffer, one for the source, for the new data that comes in. And here we're basically gonna say that if we have enough, if this is more than or equal to bytes needed, we're gonna produce another item. Now the thing is also we actually need to, because the problem is also we can't actually return more than one item at a time due to how this kind of works. So we have to kind of have a little, maybe we need to have like a little internal buffer or something actually, because if this like loops through, well, actually we don't really need to. Actually we could just wait with getting more data here. We can actually check here. We don't even need to call source next if we already have a next item to kind of the thing is we don't know how large the next item is going to be. It could be like as large as it, you know, as it could be super large. Like it could be like, I don't know, a megabyte or something. And then we would have to buffer that. That's kind of the problem with this approach, I think. Because sure, like we receive strings, but there's no maximum limit on how large they are. Maybe I should rethink this system a little bit. Hello, Dumb Guy Codes. Welcome back. You know what? I'm gonna do this. I'm gonna disable this for now, because we don't really need this right now. I just try to build this for fun, but I realize there's an issue here. There's an issue with, as I just said, like the stream. When you have a thing like this that has like an unknown size, we don't know how much. You know, we don't know how large this item is going to be. So that's the issue. I chose to have strings here because it would be like more efficient to you know, put forward chunks instead of just one byte at a time, really. So, but we could make this into a byte stream, like just one byte at a time. But it's just so much overhead, I thought. I mean, maybe we could try it. Maybe we could, because then we solve the whole issue. Because then we can just request, you know, n items. That could also, we could build that into the stream interface. We could have a function in the stream interface that requests n items and it produces a list instead of just one at a time. and then in the byte transformer stream, we could then use that function to retrieve something of this size if it exists. I guess, what if we retrieve something less? Well, then I think we retrieve as many as we have, and then it's gonna have to return that. Okay, well, anyway, what I want to do is, now we have this byte reader stream, but the problem really is over here when we go to the evaluator, evaluate call expression, I believe, or wait, no, I think it's executable actually. Right, the problem is here, or actually no, it's evaluate binary, because the pipe operator, so the code that I'm trying to support here is gonna be, is this one here. Okay, this code, right? So I've got this working again. So this one is working now. Again, I'm gonna skip type check just in case. So that's working, yay. But when I pipe it now, it doesn't work because I've reworked how the pipe system is supposed to work into a binary expression, and now I need to like support that. So so here is like the thing for that. So now we have like left and right, you know. So we have to think about what's gonna happen, and I've thought about this a little bit, and basically what we can do is we have this context. So basically the cat context, or well, cat needs a standard in, right? And echo has a standard out, but echo doesn't need a standard in. So we're gonna have a context for the whole expression that echo is gonna use, which blocks standard in, and it pipes standard out into the standard in of the context, which is going to be the cat standard in, and then standard error is basically inherited, so it's pushed out to the outer context basically. But standard in cat, it doesn't exist yet, so that's the crux of the situation. It doesn't exist. So like in a pipeline, it's basically you have to kind of make the whole pipeline, all the stages, it feels like you have to kind of make them be like instantiated first, and then you can pipe them to each other, and then you kind of stored up the first one and everyone else. So that is kind of, but the problem is like, well, not every stage in the pipe is an executable. We're working with functions actually, so they're going to be functions. This is a function that gets called here, and we're gonna put it in like in this context. Yeah, so that's the thing. And then also like, okay, what if you have another one? Like, how do we do this? Because this is supposed to pipe into the standard in here, and then the result of this will presumably then be put in another, the same way this is put into a context, this will also be put into another context, with standard in being pushed into standard out of this one. Or, I mean, no, standard out of this will be put into standard in of this one. But also the problem here again is that we don't have the standard in yet. And also, we can't really consume the whole stream, because it could be a streaming thing. Like, if it's streaming, we have to kind of instantiate the whole pipeline first, and then stream it through the whole pipeline. But if we do it like we evaluate this expression first, you know, then this has to, we have to consume it if that's how we build it. So yeah, this is the issue now. It's like we probably need a thread here that will well, this would evaluate. So the idea is that this would evaluate into a stream, and then the binary expression would put that stream and somehow, you know, connect it to the context or something like that, and then this would also produce a stream. Because I realized also, like, the way we did executables, right? They have like standard in, standard out. Where is it? The child here. The child process has standard in, standard out, standard out, right? Now where is this? Oh, we can remove you. So the child standard in. This is the kind of the operating system file descriptor of the child standard in. It's already, you know, a file in Zig, so we don't really need to set up this whole loop and all that. We could probably, I mean, we have to do, like, we have to execute we have to kind of push it through somehow. So I have to still kind of try to figure it out how this will work with the whole pipeline here. Yeah, because child standard in, for example, this is a file, of course, and you can get a reader streaming here, for example, and then stream it into something else. And so on. But that's what we're doing here. It's just that it's blocking at the moment. It's like this is blocking until that yeah. So we have to redesign this a little bit, and that's what I'm trying to figure out. I'm just trying to find an easy way out, basically. But yeah. What's happening? Why is the LSP acting up? I can't go to this definition. Okay. Anyway. Yeah. So, yeah. That's kind of the crux. Like, my initial idea, as I said, was to turn this into a stream. And when you pipe something into something else, if this is a stream, then we try to connect it to this as a function, right? So that would be like the function standard in. So basically you would have, like, you know, we have the left is the expression, and then it's like, if left is a stream, then we would have right. Right has to be a function. So left is a stream, right is a function. And that's, yeah, that's how it has to be. Like, in a type, in a pipe, we have to kind of, I think we have to change the pipe parser here, because this has to be, or, well, no, the expression needs to be evaluated. So this is evaluated into, well, this is just cat, which with the evaluation is actually going to try to run cat right now. So we have to change this into being evaluated into a function, actually. So we can't really use evaluate expression. We have to kind of assume that this is a yeah, it has to be kind of some kind of special evaluation or something. or in the parser it's gonna, well, we already know it's a pipe though, so man, this is difficult. I'm going like back and forth. It just doesn't, I just can't see the obvious solution. It's kind of obvious to me that this should be a stream and we pipe it into a function. But then it's like, well, this isn't really a function. Well, it is a function. But really, we're parsing it as an expression. We should really parse it. Well, the expression is an identifier, right? And that's gonna evaluate it into... right? It's gonna be looked up and it's not gonna be found, and then when it's not found, we are making it into we're making it into a function that is an executable function. Yeah, okay. But okay, so when we parse this is gonna, but this, I think this is parsed as a call now, which is not what we need. Well, I guess it is a call as well, because it can have arguments. It's a call, but we don't want to evaluate the call. Okay, so maybe we don't evaluate it here. We have like a kind of a special evaluation. Well, we could have another function which is like evaluate pipe. Like evaluate pipe right hand side expression, which is kind of a special kind of evaluation. Which will give us a value. I just want the formatter to work with me here. But okay, so we have that, and then we have the right hand side is an expression. Okay. Now, okay, so at the end here, if this, so, okay, here we can do, we switch on it. If this is a call, we just return the call expression, I think. Yeah. We just return it as a value. So basically, it's kind of like a function partial application, except the thing that's not applied yet is a standard in. Yeah, we actually need. Well, it's kind of like a function though. We could make a new function. Instead of making a new thing here, we could just make a new function. yeah, we just wrap this basically in a function expression. Maybe we should do that in the parser stage, actually. Then the parser needs to have some sort of context there. No, I think it's gonna be hard to make this into the parser, to make the parser know that this is supposed to be a function. It's like everything to the right of this pipe is like a function that takes this type of standard in, and then the body of the function is this rest of the expression. It's like an anonymous function that gets called here. Yeah, I mean, I guess. Hello, Legis Barrett AI. What's up? Welcome. Okay, let me just investigate if we could make this here. Alright, so here's the parser for the binary expressions. Yeah. Right, the flattening is flattening call arguments, but we don't really care about the call arguments actually. We just need to care about creating a function on the right hand side of the pipe operators. So I think that's gonna be a special kind of operation here. Like it's basically here, like right hand side. We're gonna have to check if the operator is a pipe, then this will become a function. And what happens then? It's a function with no arguments. It takes standard in. That's going to be the same type as the standard out here. Which means... yeah, okay, well... and then the expression is going to be the rest of... well, it's going to be the right here. Because really, the binary tree is divided like this. This is going to be the first expression that gets evaluated. Well, this gets evaluated. Here's a pipe. The left-hand side is evaluated. This is a pipe. The left-hand side gets evaluated. This gets evaluated into a stream. Pipe gets evaluated into a function here. This, then the result of that will be that the pipe will call the function with this stream as standard in. Then the result of this whole thing will be a stream, which then we repeat the process. Okay. So this binary, we have to kind of, let's make a function. Let's do init. We need an allocator. And we're gonna have left operator and right. Kind of a weird place to put this, but I don't know, it's just convenient. And this would return us a binary expression. I mean, it should probably be put somewhere else actually. I'm gonna put it as another function here. So we'll do like init binary expression. Let's do self instead. We don't need to put allocator there now. And then you would be, well, let's just do that. For convenience. Alright, left is always going to be left. Operator is always going to be operator. Right is going to be some kind of right, but this is like right processed. Wanted that to be formatted, and then we can oh, and span as well. Okay, of course, right. And then we can use that here instead, so we can say instead of doing okay, it's flattening as well. Ah, oh, man, okay. Okay, let's just do this then. And then inside here we will say, I'm just gonna copy this so we have the reference. Alright, so this is gonna be init binary expression, left hand side, operator is components, I-1, payload, right is right, span, span. No, it's LHS span and add right span. There we go. Now we can remove you. And that's a lot of parentheses. Where should we draw the line? Here maybe. Wait, what? Oh, sure, let's do this. Also, no, we are gonna use it. We are gonna use it because we might create a new expression here. Okay, so let's put the thing there maybe. No, there we go. We're allocating, we're flattening, we're initializing the thing. Great. Let's do the same thing up here. So this would be try component 0 to expression self. Operator components 1. Right expression components 2 to expression self. And span is component 0. Span and at components 2 span. There we go. All right. Okay. Now, the thing that we want to do is check if. So first I'm gonna set this to be right. And then we're gonna check if operator is pipe. And it could be other operators as well. We should probably have like a function on the operator itself to check if this is supposed to be capturing some kind of standard in. Actually, let's just make that function right now. Captures standard in. And I'm gonna switch. Oops. It's gonna be pipe for now. So now we can use that instead. Capture standard in. A little bit easier to see what we actually mean here as well. Hello, scripting language. Yes, I'm making a scripting language. What are you doing? Right. So if we want to capture standard in, then the right hand side needs to be now a function. So you need to be a function. Well, what function? Well, let's do a special, let's just do a function here. Create standard in capture function. And the expression of the function is going to be right. And I think that's it. That we don't really need anything else for that. We could need this to get like the type, but let's start here. Java coding. Okay, cool. What are you working on? If you wanna share. Don't have to. Don't want to. Create standard version. Yeah, self, and then this is gonna be the function body. Okay. Now, we need a function that takes well, yeah, it takes standard in. Let's just do a string for now, and then with no arguments, and just executes the body. function literal. We don't really have function literals. I mean, the declaration is kind of weird because it adds like a name. So maybe this should be like a function literal. But that just seems also like there's so little difference probably that we should make like the expression kind of the same. Like we have the literal here. Oh yeah, the function declaration is actually a statement. That's right. Okay, well, what is this? I don't think we're using this right now. Don't think so. Oh, it's used there, but not in. No, it's not. It's not actually used. I mean, we could use it, but I would maybe rather actually change the function declaration, to be honest. Make that into an expression instead. Like, yeah, it should just be able to be an expression on its own. It doesn't need to be a statement, really. Like, a variable binding does kind of make sense to be a statement because that creates like its own context. Although you could say the same. I mean, yeah, it's also like, what should it evaluate to? Should it evaluate to its value, and which scope is it being created in? I guess it's created in the scope. Like, it's kind of the equivalent of having like a bunch of things, and then all of a sudden you have like a const s equals hello in here. Like that it just feels wrong. Which language are you used in it? So I'm programming the language in Zig. I mean, we could have it as an expression, but we ban it from being all the way in here. You have to like declare it outside, and then I don't know. Anyway, but function declarations, they can be. It makes sense, kind of, that they could be like anywhere basically. And it also helps us now because we need like an anonymous. I'm gonna make this into an optional basically, and make this, yeah, well, I'll make this into a non-statement. So we'll move this from the statements to the expressions, and I think we'll just remove the function literal because that kind of, this replaces that. It's the same thing. It's just that the only difference is that you don't have a name. Really. Okay. Now we're gonna get a whole bunch of errors, but that's fine. This had to be done. Anyway. I'm gonna fix this first. Wait, no. Gonna do this. Okay, so now this is a function declaration, right? Okay. And we need a bunch of things. I'm just gonna set these to undefined now, so the compiler doesn't freak out, or not the compiler, but the parser. Okay, so the name is null. Is async? Probably gonna remove that. Or, well, we are gonna have like function. Well, the function itself is never gonna be async. It's more like you're launching a process in background mode. That's what's gonna happen. So we're not gonna have like async. I think I want to remove this actually. Now that we're dealing with this, I'm just gonna remove that thing. And now we get all these things. Function literal doesn't exist. Let's change you to declaration. And wait. Oh, that's it. Okay. And we'll remove you. And you will remove as well. Wait. Why do we not have 4 here? Is it because it's 4 is an expression, right? While we don't have right now. 4 is an expression now, yeah. Okay. I'm basically gonna make everything expressions except for like the binding and maybe the top level type definition of the Rust or runic function. Hello NG Tantai, welcome back. Alright, Penguin. Is it called Zash? No, it's called runic. Or are you thinking about like zig bash? I mean, it is gonna have zig-like syntax. It's gonna be like zig mixed with bash, basically. Yeah, this is not a statement. This is not where we get these anymore. We should do them in the expression now instead. We have to figure out how to get them in the expression actually now. Well, I mean, I guess it's kind of easy actually. We have like function. If we have a function thing, we are going to parse a function. And I will switch you to parse. Actually, we can just parse function here straight up. So let's just remove that. And we'll change you to expression. And this will be self-alloc expression. There we go. Except you need to be function declaration. Okay, that was easier than expected. Right, so now you are not a declaration anymore. You are actually an expression. which will be evaluated over yonder. And wait. I mean, I guess the value is the function literal. I guess it, yeah. I guess it's the function ref. Runic with C. Hello, Hawkeye. I'm building a bash-like scripting language in Zig called Runic. It's like it's gonna be like it's sort of like my toy language for learning, you know, building languages. It's gonna be like interpreted, and you can see an example here on the right hand side. Although we can remove these parentheses. So basically, yeah, it's like Bash, except it's gonna have like Runic. Or, yeah, of course, it's gonna have Runic syntax. It's gonna have syntax like Zig and Bash mixed together. Runic with C. All right. So basically, you're gonna have like, you can have a for loop like this. So just like in Zig, and the string is gonna be string interpolated like this, where you only have one type of string interpolation, and this is how it looks. And the thing that's inside is a Runic expression. A Runic expression. Yeah, and then, you know, if, else, and so on. So the difference basically is going to be Bash, but the programming kind of, it's going to be like, you know, the pipelines are going to be and, you know, redirections is probably going to look a lot like Bash. But then all the rest of the syntax is going to be looking like Zig. Almost, like, because Zig doesn't have string interpolation, obviously, because it's like, it doesn't have that, but so there's going to be some, you know, since it's an interpreted language, of course there's going to be differences between Zig and this, and things that you can do here you can't do in Zig, and vice versa. We're not going to have like comp time stuff, but, you know, the syntax is going to be looking like this. You're more interested in Zig than Rust. Already know C very well. Could you mention some learning resources for Zig? There is a kind of tutorial thing with a lot of like very small and very simple tasks that you could go through to kind of get a feel of the language, I think. It's called Ziglings. That is one resource that I can give you. Yeah, I'll just put the link here. And it's basic. I think you have to kind of you have to like clone down the repo exercises, and then basically you would go from there. Read the README in exercises there. And I can do a bunch of those exercises. That would get you through like the most basic Zig stuff, basically. You would need the Zig compiler, yes, because you're gonna run programs and actually, you know, program in it. You're gonna it's basically you're gonna fix some small errors that is probably like super obvious. Like most of the it's not really like programming puzzles. It's more like fill in this blank spot, which is usually pretty obvious. But it's just to learn like the language a little bit, like the syntax and everything. And then of course you have the documentation, the language reference documentation. Now you could choose the version. Like right now, like Zig isn't really, it's not released. There's no like long-standing stable version or anything like that. But you do have 0.15.2, which is the latest kind of stable version, you could say. And then you have Master, which has like the latest features, but it's not. There's like bugs and stuff. So I don't know. It's up to you. But basically, if you want to look at the documentation, you can look at here. And it will go through, it will show you, a bunch of examples and information about a lot of stuff. It's really good, actually. I like this documentation for looking up how certain like built-in features of the language work. There's a lot of information there and examples and stuff. So, and you can choose the version as well on the left hand side there. And for downloading the language, I would recommend using something like ZVM. Let's see. Yeah. This is pretty good for downloading different versions of Zig. And then you also have ZLS, which is the language server that we can set up, but you have to kind of do it manually now because 0.15 doesn't like include it. But yeah, you would have to like if you're gonna use 0.15, you can just clone the language server. And then change the branch to 0.15, whatever version you're using. 0.15.1. And then build it with Zig for the same version. And then you just then you have access. Then you have the ZLS binary there. So a bunch of you have to set up the compiler there, but yeah. I guess you want to do that anyway since you want to learn the language. So and yes. But what I mean, have you already installed it or what? Oh, it's not the same person. Sorry. Yes, they are Zig setup. So if you already have it, then that was all unnecessary. But then others could look at the links if they want to install the compiler and the language server and stuff. Because if you want to learn it, I would suggest you actually install the compiler and try to do stuff with it. Because otherwise it's gonna be hard to learn, I think. I mean, you could read the code. You can just go online and read a bunch of Zig code. I guess. Like, Ziglinks, could you actually go and read the code there? Like, instead of... Yeah, if you go to Ziglinks, you can just go to each exercise to see what the code is. If you don't want to install it, you can go over here and check out all these exercises, which are very, very basic examples of Zig code, which all include some kind of typo or something that's that you have to kind of, so you can read, you know, what the kind of quote unquote puzzle is, and then you can look at the code and try to understand what you're supposed to do to fix it. So you could do that if you don't want to install and try it yourself, because the installation is it's super easy. It's not like a huge thing or anything, but yeah. Anyway, no field name function. Oh yeah, so now we don't have this, so we can remove it there. That's right, we need to return some kind of value here, so I will return, well, we should just return it from here, I guess. Yeah. So let's return a value now instead. And this, I mean, we have the value right here. We could just return this value here. So it's bound if we have an identifier now. So it's not certain we actually have an identifier. We'll return this value, which kind of means also now that you can have an expression like this now. Well, except that you can't. Well, you can actually. You can have an expression like this. Now you would have a function, both E and F are bound to the same function now. So you could have this kind of expression. But yeah. Okay, so this would bind it to the thing, but you might not be there. So that's the thing. Like, if name isn't available, we can't actually bind it. If we have it, we have an identifier that we can bind to. But otherwise, we just have to return the value itself. Now, this value is actually going to get moved in here, so I think what we need to do is, let's see, what do we need to do? Well, if we call this, we have to kind of return, we have to clone it and return it. And then we have to return the clone. There we go. Otherwise, we just return the value itself because we didn't use it. Okay. And you don't exist. Very good. Let's see. Okay. So what's this? Run function. Declare. Oh, yeah. So if you have an anonymous function, wait. Oh shit. No, that's fine. Actually, it's kind of weird. If you have an anonymous function, how would you recursively call it? Because, I mean, now technically, let's say we do have this function here, and let's say we have an ability to have an anonymous function. And then, could you call f? Well, yes, you can, because the function is, well, it wouldn't be like that, it would just be like this. But the function is actually defined in this scope, so it would have access to f in the closure. However, The closure is created when we evaluate this expression during the evaluation of the binding. So we evaluate the expression, and in evaluating it, we would create the closure already. And then we bind. So we wouldn't actually have access to this f here. Okay, well, there's going to be a quirk that we have to live with right now. Maybe I'll add a to-do here. If the value is a function ref, add it to the closure of the function. Right. Okay. Now we have some other issues here. Okay, so that means that we can't declare it on its own thing. If we should just declare it on its own closure. Actually, like, why are we don't need to declare it every time we run the function. Actually, is this used anywhere else? No. Okay, I'll just do this to, we don't allow this anymore. Move to where we create the closure. My age, I am 30 plus. Okay. What's happening here? We're trying to declare function arguments. Okay. Right. Now, for this one, we actually know that we have a name because it's an executable, so it has to have a name here. Only used for executables, so we can assert that let's just add these asserts. Actually, function declaration of name is not equal to null. What else can we assert? I don't know. Anyway, that's what we can assert. Shut down ST10. What? I don't know what you mean. Right, so function, oh yeah, okay, so well, if let's get the declaration, and then if we have a name, oh, We're gonna break anonymous. Otherwise, we'll break name. Okay. You don't exist. Alright, that should work. What's this? Collect symbols. Right, that should be in expressions instead. It does produce symbols actually, but we need like we need like an expression. Like, yeah, this doesn't make sense anymore. I'm just gonna ignore this part. You are what? Run statement. Oh, the type checker, right? Yeah. So let's move you to run expression instead. There we go. Easy fix. Right, run function declaration. So we might not have this now. So I guess if we don't have a name, we can't declare it. I guess, you know, technically we could probably declare it some kind of identifier. We could generate some kind of anonymous identifier, but for now I'm just gonna not do it. And here we can remove you and put you in here, I believe. There we go. Oh. Right. If we have a name, there we go. Okay. Right. So now we moved function declarations to expressions. Really nice. They have optional names. So now we support anonymous functions. And we can go ahead and try and create this anonymous function now over here. So name is null. The body will be body. The span is just going to be the body span. These things I would just say null for now. And parameters is going to be empty. Easy peasy. Oop. Well, it's going to be non-variadic. Empty. I guess, yeah. We could also have like a none. Well, this is just going to be a non-variadic. I really love that about Zig, by the way. This is so good. All right, prams. Wait, this is not the place. This is the place. All right. Okay, and that's basically it, I guess. Standard in type. I mean, of course, right now it's gonna be like a stream of bytes, but whatever. Okay, so let's see. Yeah, you're used over here. I'll just remove that so we can see the whole thing. Okay, init by inspection. If we have something correct just standard in, we will wrap it in a function now that will just be the border there. So it's basically just wrapped in a function. Yeah, that's what it is. So now when we go to evaluator and we go to evaluate binary. Okay, now the LSP works. And now we can enable this again. So we don't really need this now. We could just do evaluate expression actually. Really nice. Okay. Let's get rid of you. And okay. So we've got the left and right hand side of the pipe. The left needs to be a stream, the right needs to be a function. And now we should be there actually. So what do we do now? Yeah, that's the thing. I'm just gonna be 1 second. I'll be right back. Right, there we go. Are you guys learning Zig or what? What's going on? Okay. Now. Yeah, so left is a stream, right is a function. Okay. The thing is, we kind of need to do some kind of call now. We need to call the function, and we just plug in the stream to be the standard in. So if we say the okay, let's just go with it and we'll see where we end up, because there's gonna be some, like, how the streams are gonna get consumed is gonna be the thing that's gonna happen here. When we produce the stream. Okay, well, let's see where we go with it. So first, the left is a stream, so we already have this stream. Now it's a stream of values. Now really, it's gonna be a stream of strings. That's what it is. It's gonna be. But we don't really have this yet. But let's pretend we have this stream. Okay. So then we say scopes push frame forwarding. We can add height here. To the label. Okay. Now the forwarding is a bunch of these options. Oops. Oops. Okay, so the reader will be mapped to the stream somehow. So we would have some kind of, you know, init with stream or something, and then we're gonna do left.stream. So that's that. And then standard out. Hang on. When we call the function, we grab standard in. Yes, that should be correct. Standard out should be the outer context. So standard out is just that's just inherited. As is standard in. Yeah. Yeah, because I'm kind of thinking that that should be good. It's just standard in that's changed. Standard in is now this stream. It's gonna pull from this stream basically. And then when the function is called, it's gonna create a reader on this standard in, and it's gonna try and read from it. Okay. And actually, what we could do is we could say the streams could actually have a reader interface on them. We could actually implement a reader interface probably on the stream. Okay, so that's our context, and then at the end we will also pop that. Let's just do this. I don't know what's going on, but nice. All right. Did you figure out the streams? I'm trying to. I'm trying to make it work here with the pipes. I'm working on the pipelines now. So basically what we have here is the left-hand side of a pipe is now supposed to evaluate to a stream. And the right-hand side is actually now a function. So it's always a function because the parser actually forces it to be a function, basically. And then it's up to the body of the function to kind of connect standard in to something. But that's going to happen with the call here. As we can see, we're going to push a frame where standard in is now the stream of the left-hand side of the pipe. And standard out, standard is inherited to the outside scope. And then the idea is now we call the function in this context. So it's going to read from standard in, which is the stream. And then it's going to forward standard out, standard error to the outmost context. And since then you would say, but hey, what about the next pipeline or the next stage in the pipeline? Well, this is actually a tree like this. So the first thing that's going to be evaluated is this part, which is going to turn into a stream of strings. And then it's going to be piped, like in here, into cat, which will put it to the out, standard out, standard out. Actually, wait. But that, yeah, then this will turn into a stream. Hang on, no. The first, this is what's evaluated first, right? So in here is a binary expression. The left-hand side is going to be evaluated to a stream. But we need that to be in a context now. We need this to be evaluated to a stream. But the left-hand side is only evaluated in a bare, so this would actually push it out to another context. So this wouldn't actually work. We actually need to surround the left-hand side in a context. Yeah. So so we actually need another scope here, or another frame forwarding. And I'm gonna move this up here. Oops. You will be the left hand side. And well, standard in, I think, let's see. So the left hand side. So standard in will be blocked, I think. Yeah, it's the left hand side is always blocked on standard in. And then standard out is gonna be what? Standard error is always gonna, I think standard error is always gonna like be inherited unless we have like some kind of redirection, but we don't have that right now. Okay, and then we evaluate left, and then we pop the scope. Right, so the only thing missing is this, and what is standard out gonna be? So this gets evaluated, so then this is gonna get evaluated. What is standard out? So I think we need to like capture this in a stream somehow. We need to have like a stream capturing thing. I presume you don't have a subshell like bash, so the parentheses don't have special. Yeah, don't think of this as subshells. They are just expression, like parenthesized expressions. It's just like grouped expressions. And we actually have block expressions, so you can have block expressions like this, which would actually create its own scope. But it's not a subshell, so it still inherits environment variables and stuff like that. But it works more like a programming language scope, where the variables inside are not leaked to the outside. However, I'm not sure exactly how I want to do the subshell. I know that it's probably going to be a nice construct to have, and maybe we'll have like a special syntax like this, or I'm not sure, but it's not gonna be parentheses. It's just not gonna be parentheses because it's just too common of a especially in programming languages to have like a grouping expressions like this. And this is just to demonstrate the order of operations here. But this would be in the language. This would be equivalent to having no parentheses. So these two are going to be exactly the same expression. This is going to get parsed into this. Yeah. Well, it is parsed into that right now, actually. Okay, well. Okay, yeah, we need another mechanism now. We need a way to capture all the standard out in the current scope to some kind of stream. We need to set up a stream that will capture the standard out. And then you can read from that stream later, because we need it. Let's see, so let's think about this. This will create a stream, and then we need to consume it into standard in of this one. Yeah. So yeah, that's what this is gonna be. So actually, do we need to pop this frame at like later then? We don't pop it there, we pop it later. I mean, it doesn't really matter that much, I don't think. No, it doesn't matter. We evaluate this, get the stream, put it in here. Yeah. We just need to be able to capture the stream output. That's what's missing here. All right. The thing is now is like we're gonna have a child spawn that is kind of lingering now, because before we just call a function, it will consume the whole thing, it exits. Now we need to have something that sticks around somewhere. Maybe we have like a hash map of processes or something. Process ID to child. And with ampersand would be echo hello cat and pipeline 2. Yeah. That is the goal. Like the goal is to be able to support all those pipeline things. Well, I say all, but all the basic stuff, I guess, like the normal pipe operator, the AND, the OR, redirection, And redirection is also gonna be like, yeah, it's gonna be able to redirect to files, but also it would be cool if we could redirect into a variable. I guess that would be a binding as well, I guess. Maybe. I don't know, we'll see. Like if you could, you know, echo hello, and you redirect into, let's say we have var s is a string, we redirect into s. So that would just put it in the string s. Something like that. I'm not exactly sure about the syntax, you know, it's just an example here, but it's just to demonstrate. But yeah, that would be kind of cool to be able to do that, because you can have like a, you know, then you could just think about pipelines, and whenever you need like an intermediate step that's going to be captured, maybe you can redirect, you can like duplicate maybe even into s, but then also continue so that you can capture this part in a variable and then do something with that maybe, and then keep on going here with something else, you know, blah blah blah. So then this part will get, you know, s will capture this output, but also it will duplicate the output over here as well. But I'm not. I need to study the bash syntax a little bit and how you duplicate things, because to be honest, I'm a bash noob. That's why I'm building this language, so I don't have to deal with that. But it's kind of ironic, because in the process I'm gonna have to learn bash, because I want to I don't want to make it too alien to people who already know bash. I want to have like, it's gonna feel like programming in bash, except you have these other programming things. Like some of the things, like the subshells for example, are gonna change, but I want to keep kind of the same behavior in most cases, if you see what I mean. So you don't have to, like, if you want to switch from this to bash, or I mean the other way around, it's not gonna be like learning, well, it's gonna be, you know, you have to learn, you know, the syntax and everything, but with the pipeline stuff it's gonna be pretty straightforward, hopefully. Yeah, standard to s, yeah. So I'm probably gonna keep the syntax for redirecting. It's just that I don't know how to redirect, like, you know, when and why and where do I put the ampersand, where do I put the number, and why and where and when and how, and, you know, I don't know that. I'm not that familiar with that. I know that 2 stand for standard, 1 for stand out, 0 standard in. Or is it 1, 2, 3? No, it's 0, 1, 2, right? What is 3 actually? I think I've seen 3 as well. Yeah, so I'm gonna study that a little bit, and, you know, basically mimic a lot of those behaviors. But yeah, with some other syntax and more features, or yeah, it's not gonna have more features than bash. I'm not gonna claim that, but it's gonna mimic some of the stuff, and I'm gonna add some of my own things. Yeah, 0, 1, 2, yeah. Welcome back, Penguin. Will it be able to have 2D arrays? Yes. It will be able to have ND arrays. Like right now, you can have an array. Excuse me. Let's say you want to have an array of strings. Arrays look like this. So you have like a bunch of strings in here. That's an array. And then there's no reason why you can't nest it. So now we have a nested array. 3 is file descriptor. Okay. Is it a specific file descriptor, or is it just file descriptor number 3? That happens to be some kind of file somewhere. Because I know the number is a file descriptor. And you can basically, I think, isn't it like the inode number or something like that? I'm not sure. Which I recently learned about as well. Yeah, so this would be a 2D array here with zig syntax, except for, you know, the types, but yeah. Usually used, okay, so as a placeholder, okay. So is it a special file descriptor? Is it the exec3 and 1 3 greater than and 1 ampersand 1 3 is file descriptor assigned standard out 2. Okay, so that redirects standard out to 3. Because in my mind, it's looking like it's the other way around. Like you're saying 3 goes into 1. And that's why I'm confused when it comes to bash. Or is it the other way around? Because usually you have like the arrow on the left hand side, and on the right hand side you have the thing it redirects to. Like that makes sense to me. Like echo hello goes into file.txt. This makes total sense to me. But this does not make sense. What is happening here? exec 1 3 3 1 greater than ampersand 3 space 3 greater than ampersand hyphen. The file descriptor standard out is replaced back to 1 and reset. Well, the file descriptor of standard out is replaced back to 1 and reset. So are you saying that you're kind of changing the number of standard out? When you do 3 greater than ampersand 1, what does that do? FD assign standard out. Okay, well, whatever. Yeah, so I'm gonna try and do these kind of things. I guess the syntax, I mean, I had a philosophy of having the syntax kind of make sense for me firsthand. But then I also have the philosophy of I don't want to change, I don't want to change the whole thing. It's gonna look like bash at some point in some cases, but in some cases it won't look like bash. So the redirection part, I still don't really know exactly how I want this to be, but also I would like to know more than, okay, well, it's great that you show me these examples, but then it's like, okay, well, in what situations would you want to do this, and could there be another solution that is better or something that we can like build in and use instead, that is less confusing. 3 becomes whatever standard out is, and then reset at the end. Okay. Right. All right. Well, yeah, great. I mean, it's kind of good also to know about those things like a little bit ahead, because I might have to, I don't want to run into the situation over and over again where I have to like, oh, well, bash works like this. Okay, well, now I have to rebuild my system again, like to support this new thing or something like that. I'm trying to build it, you know, with a bunch of stuff in mind, but you know, you never know. There could be a curveball somewhere that's like, okay, well now you have to change all of this. But yeah, I was thinking a string variable could be similar to a file descriptor. Oh, I see. Well, all I'm saying here is basically standard error is gonna just be captured, like redirected into the variable s, which has to be defined, by the way. There's no magic spawning of variables. It has to be defined, and it also has to have an initializer. So this is the minimum here you can do. Well, you can't omit the type because it's gonna be coerced, but this would just put it in s. Like it's basically just like taking this step, like assigning s to echo hello. That's the kind of the same thing. Well, not really actually, because this is like standard only, I guess. No, but yeah. But I don't know about the numbers, man. That's confusing. Like, how would, like, it's pretty. How would you know which number is which? Like, you don't really know. It's like very context based. I was thinking a string variable could similar to a file descriptor. Right. If you want to support bash down the pipeline to the pipeline operator, it becomes hard to reason about. I guess that's why ZSH didn't change much in syntax. Yeah. Yeah, I mean, the basic pipelines are not that bad, but it's maybe like the redirects are gonna be. I'm gonna have to think about that, because it's basically it's like modifying this part here. So normally this would be a stream, right? And it would, you know, if you pipe it somewhere, then that's gonna be a whole context thing. But then you also have this modifier. This is kind of like a modifier to the expression here. You can also just have a stream. Let's say you have a stream and then you redirect whatever there. Now this is probably not going to output standard error. It's not really outputting standard error. So this will be empty. But basically like this. This could be, you know, how you could also just take a stream, because this is a stream, and then redirect to s. So basically this could also be like a post unary operator or something. I don't know. That modifies this previous stream here. Maybe. I don't know. So yeah, this could be an expression which is then piped to something else, which then kind of changes the thing a little bit. But because right now this pipe is changing how this is executed. If this was on its own, it would be different. Now it's changing because now we need to capture this output, pipe it into here. So there's a whole bunch of stuff happening now, and the same thing applies here. So it's not really just, you know, we have to take the whole pipe into account. I think we'll see. Well, I'm just guessing here. It's so hard to keep track of everything that's happening here because it's a lot. But yeah, it would be cool to get the basic pipelines working, and then maybe we can see how we can like augment the things. All right, let's think about how we can capture this stream here. So as I said, maybe we should have like a map of process IDs that are currently spawned in a table, or you know, a string hash map, or not a string hash map, but a process ID hash map. Process IDs, are they just they are just some kind of integer. Oh. You are, oh well, the pointer, it's the pointer. I mean, if it's a stable pointer, it could be. I'm not sure if is the handle stable. Don't they have to be stable? If you're gonna. In Bash, the pipeline is not just capturing the streaming. Yeah. That's what I want to do. And that's why I want to turn it into a stream that we can call next on to consume it. Instead of spawning the child, try to stream to a context, wait for the child to be completed, and then continue evaluation. What's going to happen is here, for example, this gets turned into a stream that you can like call next on to get the next item and so on, and we're piping that into standard in this context. So this cat will be called in a context where the standard in is the reader of this stream. So this would read from standard in, which is this one, standard out, and then the standard out. But then we don't really wait for this to complete. Of course, we just spawn it, and the idea is now that I have a list, like we're keeping it in a list, and then when the stream ends, we kill, or we handle the process, and then and that goes for all of these though. Then so then this output will be kind of the result of this whole pipeline here. This will be a stream in itself. This whole pipeline will be a stream as well. So then now this expression is a stream, and then we just repeat the process here. And so as long as this consumes this stream, this stream can end, right? And when it ends, we handle the process end as well. But this could also end, I guess. So if this ends prematurely, I guess we have to also end the whole thing. Something like that. Window handles are stable, opaque references. Okay. So we should be able to, say handle equals some other handle, and that should be the same thing. So we can treat them as basically IDs, like unique IDs. And this is just a I32 Windows handle. Wait, why is it now just using that then? Why do you have a separate here, and then here you also have a handle? Okay, a C int I32. So it's all numbers or things you can, except for this, which doesn't have processes, I guess. Oh, so you can't spawn processes in WebAssembly. Well, I guess it makes sense, maybe. Yeah. Okay. Well, that answers that. So we can treat ID as something we can equal something else. So we could probably make a map out of that. So if the evaluator, we can have like a child map, probably something like an order array hash map, only through one C. Okay, And this would be process ID or child ID. Okay, and then this would be the child. I wonder if there's like a built-in thing to get all the children. Maybe it's like operator system dependent. Oh, here you can get this. Oh, I didn't know that. Okay. Okay. Why are the colors weird? Wait, is it managed? Let's do unmanaged. Keep with the patterns. Why are the colors so weird? Okay, well, anyway. Oh, maybe because of this. Okay. And then we have like a dnit somewhere. Well, okay. What if we have like loose ends at the end? That doesn't make sense. I guess you could have a script that does something at the end, you know. Well, that's a bad example because that's gonna kind of block. But I mean, yeah, okay, well, let's just do like server log. Let's say this, and then we put it in the background. But then we end, right? But this should still keep going, right? We have to say that, okay, well, if we go to the end and we still have children running, then we will just keep on running. Maybe we can even put the parent to sleep or something. Or could we or maybe we detach? No, we don't do that. We just wait. What happens? Maybe we could just put the parent to sleep or something. Like, could you put the parent to sleep like indefinitely? Or actually, maybe that's a bad idea. Maybe you need to actually clean up. Now, this is not gonna end until, I guess, one of the children, like all the children, like errors out. No, we just call like wait on all of them. Yeah. Or join or whatever it's called. Okay, well. So, but that wouldn't really happen here though. I'm gonna put that, actually, you know what, let's not do it unmanaged. Let's make this managed. And then the init will, man, I want to use this arena, but I can't. Okay, well, it's not gonna matter that much anyway. Well, let's just do init. Okay, yeah, because we can just call the init here, and that's fine. There we go. And then it's like run statement. yeah, wait, this is called in like a parent thing. Let's see, this is called here. That's right. So when everything is done here, we now have to kind of wait. So yeah, now we do like for evaluator child map values child, and then we just do, is it wait or join? Wait. And we don't really care about the termination here. They are like async processes. How would you deal with the terminant signal? Unless you want to print something out, I guess. What's a wait error? Spawn error. Oh man, that's the thing as well. Like wait. Sometimes wait is actually starting the process. Oh, you have to call wait for spawn. Spawn may not report all spawn errors, as I've seen, such as error invalid XC. This function will block until any spawn errors can be reported and return them. Okay. Spawn reports everything. Wait for the child to report any errors before exec. Okay, well this makes me feel like maybe we need to actually have them in threads. Wait for the child to report errors in or before exec VPE. It feels like it kind of, I don't know, it depends on the system. Right end close by close exec at the end of time. Exec VPE call indicating success. V arguments array of pointers represent argue list. E environment of the column specified. Okay. These functions duplicate the actions of the shell in searching for an executable file if the specified file is slash character. File is sought in the column separate list of directory path name and path environment variable. If this variable isn't defined, path list of files. Right. Yeah, because I've seen like when I call spawn, it doesn't report that the command wasn't found. It doesn't report that. It reports it until I call wait, which is annoying because I would like to know if it has actually spawned or not. Like spawn doesn't actually spawn it. Or, well, I don't know. It doesn't run the process. I want to be able to start the process and have it running in the background, basically, and then wait for it to complete at a later stage. So I'm reading here on how this specific function works. So that, you know, if this if this blocks the whole thing, we actually have to have a thread here. If the specified file includes a slash character path is ignored. Okay. Permission is denied for a file fail. All other exec functions take their first argument, path name. Replaces current process image with a new process image. The functions described are okay. So, but that means the sig has to fork, right? Or does it just block it? You need to do a separate thread. God damn it! I thought that this was I thought it did, like, it spawned a child process that you could, like, just that was running in the background and you could just wait for it to complete. God damn it. Okay. Where is that? Read int. What the hell is this? Error pipe. Fork. Pipe. What are you doing? Pipe? Yeah, you're calling these things the pipe stuff. I've seen, like, I read some C stuff about, like, piping. The problem is, though, that we can't really use that for, like, generally. We could try to use these, you know, the pipe system for, you know, like executables. But I mean, maybe we could actually, because it's just like reading a bunch of bytes. But basically, if we want to support like typed pipes, then we would need the construct in the language as well. It wouldn't really work with using these things. But it could be an optimization thing. If we only have byte streams, we could use like the built-in stuff instead for those things under the hood, like. But really, I'm not that worried about like optimization in this language that much. So OpenZ. What is this? Where is the fork? It's saying fork here. I'm not seeing any forks. We're doing some pipes. Ignores. Dev. Okay, so that's dev now. And closing that. Okay. Alright, so it's checking like if we need to open dev null or not. Right. Okay. Interesting. And then we have the something here. Okay, non-block is true. On this pipe? Yeah, on the pipe, okay. Destroy pipe, prog pipe, okay. On the error, then we have an arena. There's some fork somewhere here. Let's just search for fork, I guess. Aha. It's down here. So we are forking. Okay, but this whole thing is spawn, right? This whole thing is spawn, but apparently some of the errors does not get reported until we call wait. Set up child IO. Right. This is kind of doing. This is kind of close to what we're trying to do as well. All right. Changing directories. There's some IDs here. Group user process group or okay. All right, so here expand arg0. What is this? Expand? No, expand. Yeah, okay, so if we expand, we expand. If we don't expand, we don't expand. Interesting. Why wouldn't we just send this in here? Is this a different enum or something? No. Like, wouldn't this be the same thing? Okay, I guess what you get here is the switch, like exhaustive search or exhaustive options, cases, whatever it's called. So if you add another one, you would like have to implement it there. Fine. But then it's already in here though. It's just passed in here. And here you also have a switch, so okay. Well, okay, well anyway, fork child, child of fork causes no return, okay. Right, int fd. Okay, so this is the one that actually executes the thing, I think. Maybe. argv is mutable? What? Is it? Okay, well, anyway. Oh, it's a different type. I guess it has to. Oh, I see. Now I see what's going on. It has to be com time known, so that's why you have to have a switch. That's why you have to have a switch over here. What the hell? Where do we... Where? Yeah. You have to have the switch because expand, don't expand. Has to be comp time now. Okay, okay, okay. I see. Yeah, so this calls the actual execution function. So this is part of spawn. So what is happening in like wait for spawn? Maybe we just need to call this. And this is the actual wait here. So I think if we just call wait for spawn, then maybe, I mean, we could do a test. Wait, I didn't change anything. Okay. Let's do like, well, I guess we just do argv is gonna be just ls allocator standard page allocator, and that's it. And then, no wait, we have to like do something like sleep or something. Is sleep a thing? Okay, sleep. There we go. Sleep 2. Okay. And then we echo, or so we're gonna do here, we're gonna do child init, child spawn, child wait for spawn, and then child wait. So we know each step of the way. So if we get to wait immediately, this should work. No, your void, you are turn. Okay. And then of course, end. Okay, it even goes to wait, that doesn't make sense. No, it can't. Oh, yeah, it does make sense. Okay. Okay, let's actually do. No, because then that means that we do get past wait for spawn immediately. So we should be able to call wait for spawn. So let's say we do like a typo here, And you can see that wait for spawn, and then we get file not found. Okay. So we should be able to do that. On Windows, it should already be, you know, these two happen. Well, spawn already reports the same error. So, yeah. So then we don't need a separate thread because Zig already does the thread. Awesome. I think. It did a fork anyway. So yeah, so here we do wait. Yes, very good. And we don't care, let's just don't care, we don't care about the terminal. And if there's some error, I guess we'll log it. And no, that's fine. All right. Okay, yeah. Well, I think that's gonna be it for this time. Actually, I just realized I have to go now. But yeah, really cool. Now we have this child map that we can use to keep track of all the spawned stuff. And then what we can do is now we can just spawn them, create a stream that listens to the pipe and all that, connect it willy-nilly, and we should be good to go, hopefully. So yeah, but that's gonna be it for this time. So yeah, I'll see you maybe tomorrow. We'll see. Have a nice day. Bye bye.